Hello friends, today we'll solve some of the problems related to functions. So problem number 1. What is given in this case is set A, which is 1, 2, 3, and set B is 4, 5, 6, 7. And they have given the function in such a way that 1 comma 4 is ordered pair, 2 comma 5, 3 comma 6. This is the relation or the function. What does this mean is f of 1 is equal to 4, f of 2 is equal to 5, and f of 3 equal to 6. Be a function. Show that f is 1 to 1. So this is very simple. According to the given function defined, let's draw a arrow diagram. Say this, if it is A, set A and set B. What are the elements in A? That is 1, 2 and 3. Elements in B, it is 4, 5, 6 and 7. Now we'll see, according to the given function, 4 is the image of 1, and then 2 is the image for 5, 3 is the image of 6. So you can see every value of x, or the images are distinct for a distinct value of x. None of the value of x. So suppose if f of 1 is 4, f of 2 is 5, and f of 3 is 6. None of the values of x has the same image in y. Therefore you can say function f is 1 to 1 function. 1 to 1 function. Okay, I hope this is clear. We'll next move on to second problem. What is given here? So show that signum function where f such that it is related to our real numbers, given that you know what is signum function. That means, as I've already told, when x is greater than 0, that means when you select a positive value of x, the value f of x value will always be 1. If you substitute x as equal to 0, it will be equal to 0. And whenever you select a negative value, it will always be 1. So if I say select a set of numbers, say x, let me take, for example, I'll take 3 positive integers or real numbers, and if I take a negative 2, okay, what will be f of x? When I take I can write the function like this. Say if I take a value as 1, the f of x will be 1. When I take value as 2, f of x will be 1. 3, x is 3, f of x will be 1. If I take the value of x as 0, f of x will be 0. When I take f of x to be minus 1, when I take a value of x to be minus 1, the value will be also minus 1. When I take minus 2 for x, value will be minus 1. So with this, let's draw a arrow diagram. I've just taken a couple of examples, like real numbers I've just taken for this. So with this we can generalize for the whole real numbers. Suppose if for this corresponding thing I've taken minus 1, 2, 3, 0, minus 1, minus 2. That is x, and this is f of x. That means I can take it as y. So it will be 1, 1, 1. I'll just take it as like this. Instead of writing so many times, what are the one which is repeating? It should be 1, 0 and minus 1. So whenever it's a positive one, answer is always 1. If it is 0, it will be 0. If it is a negative value, it is 2. So from this can say that it is neither 1 to 1, because it's neither 1 to 1 nor onto. Why? Because why it is not onto? Because if I take real numbers, here also I can take 2, 1, 2, minus 2. If I take here all the elements in R, because this is also R is related to R, so whatever values I take, if I take the same value, these two are not the image. 2 and minus 2 is not the image of any value of x. Therefore I can say signum function is neither 1 to 1 nor onto. I hope you have understood this problem. Next we'll move on to the next question. What is given here is check the injectivity and surjectivity. What do you mean by injective? A function is called injective when it is having one-to-one type of mapping, one-to-one function. And when do you call a function to be surjective? When it is a onto function. So injectivity and surjectivity. So if I take a function, for example, f of x, where the relation is between natural numbers, here f of x is equal to x square. Suppose if I take two different of values for x, suppose if I take x and y, suppose f of x is equal to x square and f of y is equal to y square. So x square is equal to y square, and when I say f of x is equal to f of y, so which implies x is equal to y. That means they are not equal. So you will get a distinct images for a distinct value of x. You can have a example. Suppose when you take x is equal to 1, f of x will be square of it. That will be 1. If x is equal to 2, f of x will be what? It will be 4. So you can see the images are different. So that means it is a one-to-one. You will not have same image for different values of x. So I can say it is injective. Let's check for onto function. Suppose if I take a value for x is equal to 2, I'll get the function f of x to be 4. I won't get a square which is equal to 2, right? Because 2 is not a square of any number. So when I say a natural number, say take for example first n natural numbers 1, 2, 3, 4. And what will be the function here also if I take 1, 2, 3, 4, etc. If I say 1 is square of 1 is 1, what will be the square of 2? It will be 4. Correct. So 2 is not mapped. So that means 2 is not the image of anything. So it is not surjective. So I can say the given function f, which is n to n, which is related to natural numbers, is equal to x square, is injective but not surjective. I hope you are clear this one. Let's take for example when a function is between z to z, that is between integers, that is a function is like integers, where f of x is equal to x square. What does it mean? Integers means you can take negative as well as positive. So how to check the injectivity? Suppose if I take f of 1, when I substitute x as 1, f of 1 will be 1. And what is f of minus 1? Because negative value is included. F of minus 1 is also 1. That means two different value of x has the same image. Hence function f is not injective. Let's check out for surjective. What do you mean by surjective? Whatever value of y, that means it should be each and every element in the y should be the image for the x. What about when I take f of 2 square? If I take f of 2, it will be 4. But you will not, even though 2 belongs to z, this 2 will not be the image, will not be image for any value of x, for any value of x. Hence the function f is not surjective. So therefore I can say the given function is neither injective nor surjective. What is the third? This was the second problem. What was the third one? Let's go back. Okay, here the function is related between real numbers given by f of x is equal to x cube. So here f, which is related to real numbers, and f of x is equal to x cube. Let's say for example f of x is equal to f of y. Say x and y are two different values. Suppose what will be f of x? It will be x cube. This will be y cube. So x is equal to y. That means images will be different for different values of x. If you take for example f of 1, it will be 1. What will be f of 2? It will be 2 cube, that is 8. So therefore I can say the function is injective. That means it is 1 to 1. Let's check for the next one, that is whether it is surjective or not. So when you take real numbers, here all numbers are included. So 2 is, which is an element of R, but will not be the image for any value of x, for any value of x. Hence, because 2 we will not get cube as 2 for any of the value of x. Therefore, f is not surjective. So the given function is only injective and not surjective. I hope you are clear how to identify the injectivity and surjectivity in a given function.